Your warehouse floor is the critical infrastructure that supports every part of your operation. It is thousands of square feet of concrete enduring constant traffic, chemical spills, and the weight of heavy machinery. To protect that concrete, you need industrial epoxy. But facility owners in industrial hubs like Gujarat are facing a confusing market. You ask for a quote for a 1 millimeter thick floor, and you find your inbox flooded with contractors offering to do the job for just 30 rupees per square foot. To understand that price, we have to look at the baseline economics of industrial chemicals. Pure industrial-grade epoxy resin and its hardener have a fixed wholesale market price. This bar chart breaks down the physical reality of those materials. Building a solid 1 millimeter layer over exactly 1 square foot takes about 120 to 130 grams of pure mixed resin. At wholesale prices, raw material alone costs 48 to 52 rupees. Yet, contractors quote 30 rupees for the finished job. This leaves a 20 rupee deficit before factoring in labor, equipment, transport, or profit. Providing a finished floor below ingredient cost is a mathematical impossibility. The stakes here are operational. A failed industrial floor requires shutting down production zones, moving heavy machinery, and enduring massive workflow disruptions. That 30 rupee quote is the result of structural compromises designed to hide the long-term liabilities of the product. One primary tactic used by these contractors to reach that 30 rupee price point is manipulating the application method. This is a roller-applied coating. The applicator uses a standard roller to stretch a thin layer of liquid over the floor, consuming only about 0.6 kilograms of material per square meter. An industry-standard self-leveling system relies on a much higher volume, between 2.0 and 2.5 kilograms of material per square meter, to achieve true structural density. This comparison matrix shows how volume difference changes final thickness. Comparing 0.6 kilograms to 2.5 kilograms, the thickness drops from a full millimeter to a fragile 0.2 millimeters. Applicators frequently hide this, selling a 0.2 millimeter roller coating while marketing a 1 millimeter floor. You can identify these thin coatings by their slightly uneven, bumpy texture, known as an orange peel finish. A true epoxy floor is thick enough to settle into a mirror-smooth surface. By accepting the 30 rupee quote, you are paying for a basic dust control paint job while expecting it to withstand industrial traffic. Another common shortcut is chemical dilution. Applicators add cheap solvents like Xylene or acetone to stretch a small amount of resin over a larger area. This cross-section shows the deception of a diluted pour. Solvents add enough volume for the wet mixture to hit the 1 millimeter mark on a ruler. But as the floor cures, those solvents evaporate. The material shrinks, leaving a dry film thickness of 0.5 millimeters. This tampering causes invisible damage to the floor's strength. Diluting epoxy by just 5% can reduce its final compressive strength by 35%. This chemically weakened layer is too brittle to support the weight of heavy manufacturing equipment or forklifts with solid tires. Solvent dilution creates a fragile, porous surface that is highly vulnerable to impact and chemical spills. Beyond the chemistry, the strength of an epoxy floor depends entirely on the concrete foundation beneath it. The professional standard for preparation is mechanical diamond grinding. This removes the top layer of concrete to create a rough, clean profile, and it costs between 2 and 4 rupees per square foot. Budget contractors often replace this step with acid etching. They use muriatic acid, costing less than 1 rupee per square foot, to wash the floor instead of grinding it. This diagram illustrates why grinding is necessary. Liquid epoxy flows into jagged peaks, locking into the concrete. An acid wash leaves the surface too smooth. Under stress, the hardened epoxy separates from the concrete, a failure known as delamination. The heat and friction from turning forklift tires can then easily peel that weakly bonded epoxy right off the floor. Bypassing proper diamond grinding guarantees catastrophic peeling, which makes any initial savings worthless within a few months. The 30 rupee quote relies on 3 specific shortcuts. First, material starvation. Second, solvent dilution, and finally, compromised foundations. This decision tree maps out the best path. It begins by identifying your space's primary use. For light storage, a cheap roller coating is valid, a 0.4 millimeter seal lasting 1 to 3 years. But for heavy machinery, a fully solid, self-leveling system is mandatory. your decision should be driven by the total cost of ownership. A 30 rupee floor will typically fail within 1 to 3 years. When it fails, the costs include halting your production, moving heavy equipment, and paying to have the ruined floor mechanically stripped away. A professional 100 rupee system requires a higher upfront payment, but it provides 15 years of uninterrupted operational uptime. In industrial infrastructure, buying the cheapest option guarantees you will pay for the job twice. Investing in the right materials upfront is the only way to protect your long-term operations.